Hi, so today we're going to see how we can draw random samples to generate data. In some cases, it can be useful. For example, as we saw for uh, the first few videos, drawing random samples to be able to explore the central limit theorem and other things like this. So to draw a sample from a normal distribution, we need to set a few things. If you would want to get numerical data coming from a normal distribution, in that case, you're going to set n, which is the size of the sample you want to draw. We're going to call it x bar for the mean of the distribution we're going to take the sample from. We're going to call it s for the standard deviation of that normal distribution. And then we're going to generate a random sample using the function rnorm, which takes the size of the sample, the mean from the variable that's the normal variable that we want to draw from, and the standard deviations. That's why we're setting these here. And so when I execute that, then I can observe the results that we got, or at least the first few. I could actually, because it's only 78, so I can just call the entire object, which is not going to be that long. And then also we can see when I execute the mean function to calculate the mean of this sample, you can see that the mean of the sample is a little bit different, not very far, but it's a little bit different than the variable mean that we set. It's because it's taking a sample randomly. So there is going to be sampling error in there. Then sometimes you don't want to draw from a normal distribution because you're not necessarily interested in a numerical variable. Sometimes you might be interested in a categorical variable. So let's draw a binomial distribution. So for that, I'm going to set the possible outcomes, so heads or tails. I'm going to set the size of the sample. I'm going to keep 78. And then I'm going to set the probabilities for head and probabilities for tail using the C function again. And this time I'm going to put 0.11 for head and 0.89 for tail. And then after that, I can generate a random sample. And here we can show here. So for example, in the first 10 trials, there was only tails, but in the trial 11, we had a head, and then we're back to 9 heads and not tails, and so on and so forth. And by the way, every time we use any of these random functions, rnorm, sample, or a number of others that are taking a random sample, it is not really normal as in drawing from, drawing physically from, for example, sheets of paper with numbers or with letters or heads or tails or etc. It's generated through the computer and it's really close to randomly, but it's set by the time of the day. So for example, if I generate another one, now we're not in the same time. So if I generate a second sample, you can see it's potentially different. So now let's see here. Now we can see when we compare the first random sample from a binomial distribution with a probability of 0.11 of head and 0.89 of tail. So in the first case, we had the first 10 were tails, and then the 11th was head. Now this time, we need to wait for over 20 to get our first head, okay, in the head and tail distribution, okay? So now, sometimes you want to draw a random, normally distributed, binomially distributed sample, but in some cases, you might want to draw more samples than that and just get an idea of how many heads are there or how many tails are there. So for that, you can use the random binomial trial function that's called rbinom, in which here n is going to be the numbers of samples that you draw. In size, you take the size of the trial, okay? And then the last number, 0.11, is going to be the probability for heads, if you're counting heads. Or you could put the probability for tails if this is what you want to count. And so when I execute that, now you can see we have a series of mostly zeros, ones, and twos. There is 1 4 here, a couple of 4s here. And so what it does, rbinom takes 10 coin toss with either heads or tails and counts only the number of heads. And so in the first trial, you had 0 heads. In the second trial, you had 2 heads. In the third trial, you had 2 heads, and so on and so forth. Okay, so that's what you're getting here. Instead of the variable, you now get the summary for each time you did a new set of draws. Now, you can also use the same sample function that we used a little bit earlier to generate a random sample, but instead of drawing it from a known distribution, like the normal law, you can draw it from a data set that you have where you have data and you can resample that data. Okay, so for example, here I'm using the built-in data set time series, to be more precise, CO2. And now I'm drawing a random sample. Same thing, I kept the size at 78. I copied basically the time series into an object that I called my population, and I used that to draw 78 random concentration of CO2 in the atmosphere in Mauna Loa. And so here you can see the result there. If I execute it again, by the way, you're going to have different numbers, because every time each of the individuals from the object that I call my population, each of the measurements that are there all have the same probability to be drawn. That's why we want to have replace equal true sometime, because we want to be able to draw each of the individual of the sample independently from the one before. If I would put replace equals false, then once you remove the first individual from your bag where you're distributing, you instantly increased the probability for every other individual of your bag of measurement. You take the second one, now same thing, all of the individuals that stay here, their probability of being picked at the next trial keeps on increasing over time. We want each individual to have the same probability to be picked. That's why we put replace equals true. And by the way, as you might have noticed, in the example how to draw a random sample from a normal distribution, we can do that with either a data set that contains numerical variable, but it can also contain categorical variable. So for example, here I'm making it simple, A, B, C, D, right? So I'm creating that object. I'm setting the probabilities. Let's say I want to have A, B, C, and D to have different probabilities as set here at 0.2 for A, 0.48 for B, 0.20 for C, and 0.3 for D. And now I can execute. Oh, I need to put, I didn't finish that line of code, replace equals true. Okay, and now again, we draw a sample size 78 of A, B, C's, and D's with each different probabilities. If you would, actually, with all the same probabilities, because I also forgot something else here, I should have put this. And so now I can execute it. Now we get a second random sample, but this time you can see there is not a lot of A. There is a lot less A than there were before. As a matter of fact, there is just one, if I see that well. Okay. And so, yeah, that comes in. These are different ways you can generate for categorical variable or for numerical variable random samples.